Hey there guys, and welcome back. So, I started breadboarding some stuff just because one of those things, breadboards tend to be a little bit easier to see than once I get everything soldered into this. And I decided that maybe we should make some changes in the design. So, let's look at what we're looking at here. So, first off, just for the record, here is the top plate that we printed or made yesterday printed. So as you can see, everything sits in there just fine. They fit, and the keycaps would obviously go over top of this. So one of those things, no real problem with this. But when we got over here, I started getting some ideas. So let us, I'm going to start with the paper. Plan again was to have all of our keys multiplexed. And my idea here, extrapolate out all the extra buttons. I'm just going to draw one row and the columns here. So here is our individual modules, okay? And my idea here was I'd multiplex it like this. So every single module had the same 3 wires for columns, let's say. And then it would have 3 extra wires, so each module would be adding 3 wires to do its to cross-reference the keys, basically, to multiplex the keys. So here you can see we got 3, and then each module adds another 3. Whoops, sorry, was not keeping track of the camera, my bad. So we start out with 3, that's what we start out with, and then each module just adds 3, so we go up linearly. That was my idea. And I figured even if I went to a third module, which again, at 9 buttons a module, I figured I'd never even get through all these buttons down here. So this would just be 9 wires for 18 buttons, which is pretty good. And one of those things, got more than 9 pins on the micro, so it shouldn't be a problem. So I started, that was the initial plan. Now, in the initial plan, I actually had not been thinking about the LEDs. It had not been on my mind, and it wasn't until after I started talking about toggling that you kind of need a way to visually represent that something's on the keypad. You don't necessarily have to, but I wanted to, especially because the slot for the LED is right there, and it made sense to me. So the second I added those LEDs, I realized that all of a sudden we get up to a whole lot of wires. So that was a little bit of a problem, and I was considering what to do about that. But while I was pulling components out of my box, I remembered I had a whole bunch of these 74HC 595s, okay? Now 595s are the output ones, so those could drive the LEDs. We still... but that's taking up wires. We're still taking up wires for the LEDs. Now, not as many. But if I'm going to go ahead and use the 595s to drive the LEDs, then it actually kind of also makes sense to have in 165 for the buttons. That way, inside of each of these modules, we just have 2 chips pulling or outputting all the stuff on the module, and then translating that back serially to, or accepting it from, the microcontroller from this guy. And it's one of those things, they can all share the same exact VCC and ground. They can all share the same latch because we'll just pull them all at the same time. So these are synchronous, which means that they're latching. So you set the latch, and then it records the input or the output, does not make any changes to the input or output. And then when you release the latch, it lets that stuff go. It goes back to functioning normally. So one of these things, we can cut down on the number of wires by using this pretty significantly. So I think that's what we're going to do. Now, the one issue that comes up, and the reason why we're not doing the electronics just yet, is that this has 8 pins. Each of these chips have 8 pins input output. We have 9 buttons. 9 buttons. So at this point, we're going to have to make a change to this if we don't want to have to work around the fact that we have 8 buttons. If we want to keep this simple, if the point of this is to simplify our situation right here, we'll need to make a change to this. So, with all that being said, I figured rather than me make the change and then catch up onto it, I'll go ahead and just stream us making this change, switching this to an 8-button plate, and we can do the base plate, which I skipped over yesterday. I just said it's going to be simple. And the reason why this is also kind of important that we come back here and design the base plate is because I forgot we have the lifting mechanism, the slanting mechanism on the base plate. And that's obviously not, I mean, it's one of those things. It's relatively simple to do, but it is not, I said yesterday that it would just be, you know, a box with holes in it. Well, all right, it's not quite just a box with holes in it if it has slanting mechanism. So we will go on to a part 2 stream of the physical design before we switch over to electronics. And I don't actually have any of the 165s, which is why they're not on the breadboard right now. I'll be getting them in, so we can't even do the electronics just yet until I got those guys in. Now that we've made the change from just a whole bunch of wires, jumper wires, well, not even jumper wires, it would have been a ribbon cable, but now that we made the change from ribbon cable to the these guys, we are going to have to wait a little bit before I do those. So, yep, point being. Over to Fusione. Alright, so this is where we left off, and by where we left off, I mean I made a very minor change here yesterday before I printed the top panel. Let me adjust my microphone now before I do it halfway through the stream. There we go. Alright, now I'm not leaning over. And the minor change I made was we never actually mirrored this ridge over. Remember I put this ridge in to reinforce the outside wall here. I never actually mirrored this over to the opposite side. So that's the only change I've made to the model since you last saw it. So, and now we need to change this to be an 8-button, 8-button pad. So we'll make that change. And this should be somewhat straightforward here. We can just go ahead and suppress these guys. I'm suppressing these guys just because our keypad rows and keypad columns are dictating the overall size of the box. And therefore, if I was to change the keypad columns and keypad rows to 3x2, that would shrink this whole entire section up, the section we already have. So I'm just going to suppress those for right now. And then over here, I'm going to go ahead and just suppress one of these because I'm going to put those 2 buttons back in, obviously. So let us come back over here. And actually, I can do it here. And actually, there's our bottom of case construction line, which cannot move for whatever reason. So I guess I just do it over here then, since I want to use that plane to begin with. So let's get into this component before I accidentally put something on the timeline that I don't want. And we'll just position these guys manually. Oh, actually, I am... Where's the top left corner? Oh, okay. I am in the top left corner. Okay, cool. One of these things, I never rotated these key things, and I was expecting the LED slot to be at the bottom. Clearly, that is not the case, but that does not mean that I'm looking at it from the incorrect direction. I wanted to make sure I kept the top left corner in the top left, and I wasn't rotated like this, okay? Because that's our origin. That's our origin one, and I didn't want to mess with it. Point being, so let's make you guys go away. We can make you go away now. And we want 2 boxes here. Now, okay, one of those things, 1.5 million ways to skin a cat, right? I am going to do this, actually, before I add these guys, let me just make everything else construction lines. 1.5 million ways to skin a cat. And I think the way I'm going to do this is the simple, lazy way, because that's been the theme of this whole entire project, is doing stuff the simple, lazy way instead of the hard way. Sometimes we choose the hard way, but that has not been the case so far. So what I'm going to do is keep this at a right angle and keep everything in line here. So this is just a center line running through all these guys. And if I want them equally spaced across this open expanse, right, then all these lines just have to be equal, right? And that will have them equally spaced here. Turn those to construction lines, and then we just need the vertical spacing. So that is going to be our keypad spacing is a variable we have, or switch spacing, and that would be minus the switch hole, right? Or keyhole. Is that right? I think that's right. So that says 7 right now, and that's 7 there. So yeah, that was correct. I was thinking of this correctly, and now we can just extrude those out and then reposition the switches that we already have. All is what I want. We can flip you over, and okay. And then the guys that are not in an appropriate place, so that would be this guy right here. This guy can move. We'll move you to that side of the wall, and they should actually be lined up vertically because we are keeping the same exact spacing. So if this was not lined up vertically correctly, if this guy was shifted up like this, that would indicate to me that we have an issue, that we did not do that math right for the spacing minus keyhole, because that spacing that we're supposed to keep should be consistent with the other ones, and therefore these guys should only have to move left and right. So there we go. So that was a quick, easy fix, and now we can move on to the more important stuff. So let's hop to the end. And so one thing I was thinking before we move on to the base, because the base was the next part that we were talking about, is I was thinking about putting the JST connectors in here. I don't think I have any models for them. And at this point, let's see, we need a latch. We need 2 sets of serial. Okay, actually, here's the here's another thing I did not mention. Okay, let's hop back to the camera. Where's my camera? There it is. Okay, these guys, one important thing to note about these guys is that you can basically chain them together, which is really useful. So these outputs, let's say, so these are the 595s that I have, right? The 595s are the outputs, and therefore driving the LEDs. So let's say instead of 8, just for the sake of argument, this only has 4 pins driving these 4 LEDs right now. It only has 4 LEDs on this mini pad because that's all I can fit on there. I've got to work around the buttons because, well, the alternative to working around the buttons is to keep the buttons halfway out of the, out of the breadboard. That way they don't make contact with the contacts below. In that case, had I been able to do that, or if I wanted to do that rather, I could in fact have a full row of LEDs, but it's just an example to show you what's going on, what's the entire point of it. So I didn't see the reason to have a full 8 LEDs on the breadboard, and I could not fit more than 5 of these buttons, so I just cut it down to 4. So we got 4 and 4 as our example. So anyway, that may have been unnecessary explanation, but these guys, so basically imagine I have, for the outputs, a row of 4 slots. So these are my pins, right? So if I serial means sequential, right? It basically means sequential. So if I'm feeding serial data in and paralleling out, what that means is I put a, see, it's one of these funny things where I almost need a prop to do this better. Here we go. This is what I'll do. One second. Reach over here and grab myself some jumper cables of different colors. Alright. So this is my data coming in. Green, yellow, blue, orange. Obviously it's just ones and zeros. Ignore that. I'm just using this so that you can see the order that things are coming in. So this serial feeds into here. And normally you would just feed this in so that each of these is over top one of these pins. But what if I push one more onto this stack, this white guy right here, okay? If I push one more onto the stack, then all of a sudden this green guy gets kicked out the back side, right? And now it's yellow, blue, orange, white, which, you know, may be useful. You may have uses for that. But what happens to this green guy? And as it turns out with these guys, you can chain them together so that this green guy then ends up on the next set of pins on the other chip. So what that means is we can push 8 bits. You know, again, we're talking about 4 slots at this point for pin chips at this point, but it would be 8 obviously on ours. And that means that if I push 8 bits across here, imagine that I have 3 invisible jumpers here just for sake of argument. Now all of a sudden the green is on chip number 2, the green, yellow, blue, orange are all on chip number 2, and the white is the last one over here. So that means that we can actually save pins on the Arduino by just shuffling all of our data from board to board, and that means that the boards want to connect to each other, is the short explanation of what we're going to be doing here. So we're going to want a jumper to run between each module in order to serial shift them. And actually, I know I just said the whole entire point of this conversation was to get these JST connectors into the back here where they'll get plugged in, but I actually want to double check on a couple of things just because as I mentioned, I have a whole bunch of these 595s, and the reason I have a whole bunch of these 595s sitting around is because I've never actually used them. I bought a pack of them, and I was like, oh yeah, you know, it's when I was first getting into Arduino, right? I heard, oh, shift registers, these things are so cool, I can do like a big old million LED thing, and yeah, it's one of those things that was highly unnecessary, and I never did it, therefore. So since it's been so long since I've looked at the stuff on the shift registers, I do want to double check a few things on the shift registers before I actually commit to where these holes are going to be, and properly lay it out to make sure that I am getting all the wires I actually need. So yeah, we will not be doing that. Instead, we will be moving down to the base, or not the base, the because this one's the base. This is the bottom case, right? Obviously the base. That's a joke from yesterday in case you did not watch part 1. So the Arduino holder, the master case, is what I will call it, because this is the only one with an Arduino in it. Master case. Okie dokies. And do I have a bottom of bottom case construction line yet? Top of bottom case, outside of back. Nope, does not look like I do. So let's hop up in here. One of those things, what I'm doing right here is pretty unnecessary, because you could always line it back up later, as long as you keep the same hole pattern here. These 4 mounting holes, again, are going to just go all the way through to fix the bottom module to the master case. So long as I keep that whole pattern the same, it doesn't necessarily matter. But one of those things, it doesn't necessarily hurt to do it this way. So, and it's a little bit quicker. So since that is the case, let's see. This is bottom of bottom case. I should say outside of bottom case. Yeah, we don't need that of there, right? You understand what I mean. It's too many words. Alright, back to the master case. Grab that plane I just made. Project out the bottom. We ended up on the top because, of course we did, because we clicked on it from the top. And now I can turn the rest of this stuff off so that I can focus on design. So, again, we will go ahead and use these hex nuts as the way we attach, so we're going to want to capture these guys. we're also going to need to add back in the M3 holes, because again, we're just projecting the face, which does not have the M3 holes in it, as discussed last time. And then, as always, and it's one of these things, I've been doing this separately for everything that gets derived, but we can always circle pattern around. Actually, I don't recall, did I do it separately for all these, or was I using circle patterns for the attachments to the what do you call it, the slide cover, or not slide cover, slide attachment rather. I cannot remember. And 2 millimeters is fine here on the outside. Again, what we're doing right here is making the captures for the nuts. And I will come back in and redimension the 3 millimeter hole in just a second. Will not forget that. So that's equal to that, that's equal to that, that's equal to that, and that is 3. Oh, come on. Oh, click the wrong thing. That is equal to that, and that is 3 millimeters. There we go. And now we are ready to extrude. Actually, so one of these things. Interesting. Okay. I don't know. So if we want to, we have an option here. If we want to, we could run. What would this distance be? How big do I need to make this? Let me check the height here. Actually, so I know the Arduino Micro is going to need its own thing, so I can't just grab one of my whatever you call these things. What do you call these things? Let me check the case really quick. 1 second. Where are you? Why do I not see you? Oh, there you are. I guess that makes sense for you to be there. I have the sockets, IC sockets is what I have. So I will be using IC sockets on the PCBs for the shift registers, but the Arduinos do not fit into IC sockets because they are not the same footprint. So it's going to need its own with the headers. And let me go track down that bag now. Alright, I just pulled out the bag from the demo kit so that I can check what the overall height is that this micro was with the PCB that it was attached to, so that I know how much clearance we need for this master case. And we need a minimum, and by minimum I mean like the exact height is 16.75, and then obviously we don't want this thing literally smushed between the top and bottom, so let's go a full 25 millimeters and call it good. So anyway, what I was talking about earlier, we have an option here if we want to. So that's 25 millimeters is why I wanted to get that. So if the master case depth is going to be 25 millimeters, and we look at the bottom case here, right? Or actually, I guess we need the whole entire thing. So from top to bottom. So if I take this measurement here from the top case to the bottom case, that is 14.5 plus 25 is 15 plus 25 is 40. So about 40 millimeters. So if I have, yeah, I should have 40 millimeter M3s. Yeah, definitely. I have all the way up to 65. Oh no, those are M4s. Darn me. Let's see. M3s? Alright, yeah, I have up to 40 in M3s. Which is exactly what we have right now. So we just barely make it. So if I want to, instead of having the top case right here have the captured nuts, which was my original plan. So this is the lid on the master case, is what this is. Instead of having the lid of the master case have the capture nuts, we could eliminate the lid on the master case altogether and just have it go right up against the base here, which makes a lot of sense. Like, the only reason I have it right now is for this to attach, and that saves us 25 millimeters on our bolts, but it may be worth it just to go the full 40 millimeters all the way down. And now we do have to be a little bit careful, just because 40 millimeters, you know, it's one of those things that's at the very end of the, nah, it should be fine. I was going to say that's at the very end of the bolt, but even if it doesn't make it all the way through the nut, it's probably going to be all right, right? Nah, nothing could go wrong. All right, yeah. So that's the new plan. New plan is we'll build the case, and then we're going to put these captured nuts on the bottom of the case, and we will not have a lid for the master case. Alright, cool. So that is the new plan. Because again, that just saves us on so much. Let me rotate this way. And we will now go ahead and throw the wall in that case, because I will not do it like that. I'll just do an offset. Minus 2 millimeter wall. And we'll extrude this out, and then we'll extrude the bottom. So this, again, is going to be 25 millimeters. And that will be 25 millimeters actually to the bottom, as in the outside bottom of the case, because the bolts I have are 40 millimeters exactly. So we need to save that space right now, is the problem. So that means that obviously we have slightly less space on the inside for the microcontroller, but the microcontroller, again, with the headers that it was on it, only came out to 16.75. So we had an extra 8-ish millimeters. So even if I take 2 millimeters away from that, that's still an extra 6 millimeters. So we should still be fine. So let's extrude this guy out now, and this is going to extrude from the bottom again, as previously mentioned. And I think I will do the thing that I did before. Well, let's get this in place first. So we're going to extrude this from object, that, and this needs to go up to, because again, this is the absolute maximum that we have right here. So that's going up to. I'm going to go ahead and turn the top and bottom case off now. And then I will do the captures up here. Doink, 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 doink. From object. There. Up 2 millimeters. Up 2 millimeters. Again, orientation. And join. And then I will go ahead and round these guys out to make them look nice. Just because I like them looking nice. It's going to print in this orientation anyway, so should be fine. Cool. Maybe I don't want them rounded that much, just because that does cut down on the distance. So let's go ahead and look at that really quick. Let's take a section analysis. Section analysis. And open this up. Slide him over. Attempt to slide him over. Please, can I have the arrow? There we go. Oh, that was too far. Too far, too far. Okay, fine. You're going to be a pain in the butt. Minus 25. Minus 15. 10. I much prefer to grab the arrow. So this is what I was talking about. Let's see if I can find the widest it is. So somewhere around here. 9, 7... Yeah, 8. Okay, so 8 is more or less the widest this nut is right here. So I was just looking, you see this corner to there? I was thinking maybe I want to round this less so that we have a little bit more distance there, but it doesn't look that much off from there. I'll go ahead and take a inspect here and grab, let us say that to, I don't think that worked the way I wanted it to. Whoops. That to that, and we'll see what it says. So it's saying 1.45. Again, I try to go like 1.2, but this is just a captured nut. We're not going to be cranking down on this bolt terribly hard. So since we're not cranking down on the bolt terribly hard, I'm not particularly concerned about it exploding out the top here. So I'm alright with the nearly 1.5 instead of a 2mm. I'm happy with that. Because again, it makes it look nicer in my opinion. Obviously it won't look this nice because we're 3D printing FDM. But close enough. Close enough. Turn that section analysis back off. And let's go ahead and call this yellow, I guess. The orange is all the way at the top, so it, if I recall correctly, so it shouldn't be too close, right? Slide attachment is orange, yeah. So we got a little bit of separation between those two colors since they're, you know, close in color. All right, so anyway, yeah, my original assumption was that this is the only thing I was going to be designing, again with some holes in the back for the wires coming out to connect the other modules. Which is why I did not do it on stream because obviously it's just a very simple box. But now we need to add the tilt function. So we have a couple options here. Basically our options are the first option is how we want the tilt mechanism to function. The second option is where we want the tilt mechanism to function. And actually there's a fourth thing to consider here, which is how I am keeping this on my desk. Let's see. So I was thinking of having it be a separate thing that gets bolted onto the bottom here with separate holes. So I was actually, instead of, so far, let's do this really quick. So far, everything gets bolted through, all the way through, right? So this, the green case right here would get bolted to the top of this guy for the next one up. And then this blue case, the blue top section here would get bolted all the way through to the bottom here is our current plan. Actually, I take that back. The first thing I said was inaccurate. The blue case gets bolted to the orange case. That's what I should have said. I was being stupid. I apologize. A blue case gets bolted to the orange case, so the bolts go all the way through to the bottom of the orange case. The blue case gets bolted to the bottom of the yellow case in this situation because this is the master case right here. So running the bolts all the way through just kind of keeps everything in line, and I shouldn't say in line, but it keeps everything uniform is the idea here. So we're using all the same mounting bolts, but I think I will add a separate mounting pattern for this tilt and mounting feature component that we're about to design is what I'm getting to. That way we don't have to continue running the bolt all the way through to the tilt mechanism is the idea. Especially because at this point our bolt running all the way through here right now is 40mm, which is the largest bolt M3 bolt I have right now. So I don't really have the option unless I want to go out and buy M3 bolts is one consideration. I should change that to say M3 bolts that are 45mm long, since generally they go in 5mm increments, and we need slightly more than 40mm in order to accommodate the plate. So we will be using a separate hole mounting pattern is the TLDR. So yeah, tilt mount is what I'm gonna say. And actually before I do that, because in theory you could swap this out, because this is going to be a whole entire another 3D printed part, you could in theory swap this out for another mount, and therefore I will just set a mounting pattern right now and then match that on the tilt mount. So let us go ahead and turn the rest of this guys off for not for half a second, for a long time. We're not coming back to them for a while. This is an inside of bottom. inside bottom of master case. Grab that, project that out. Construction lines, you guys know the drill. I'm going to, so it's one of those things. I like the holes in the corner more than in a cross pattern. So instead of going hole, a diamond shape, I guess you could call it, instead of having a diamond shape, I like it in the corners better, is my thought process here. That may just be my opinion, and it frankly may not be, we may run into a situation, rather is what I should say, where maybe I shouldn't have done this, but this is where we're at right now. So this is an M3, because again, I try to keep all the bolts the same exact size when I'm doing a design. I try to keep all the bolts the same size if possible. If not possible, then I'll cry about it. So there is that. That's going to be 5.45. 5.45. This is my reference circle. You guys know how this works. This is 2 millimeters, obviously. And then, so actually, if I wanted to, I could move this tangent to that line, because as you will see when I do that, not that guy, that guy. Huh? Oh no, I guess because I'm on the diagonal right now, but my point being is that the outside circle, my 2 millimeter circle, is still within the 2 millimeter wall, was my point. So I could, if I wanted to move it out from the center and get it as close to the corner as I could do that. However, I don't know if that's really necessary. I think I might just tangent this up to that. And just for the record, the reason why both of these sides did not hit, so this is not in contact right now, is because we're not actually square right anymore. We started out square, but as you can see, that did not work the way I wanted it to. So 73 millimeters on that and 67 millimeters on that. And the reason why we're longer here, in case you did not catch it, is because we added the slides on the side and we kept everything square. If the slides were outside of the central box so that it wasn't square, then we would still be square on the bottom here, but we are not. So that is why the two edges do not line up. Let me get back to where we were at, and again I'm going to, I undid this one, but there we go. Now the one thing I'm a little bit confused on is that I am not constrained right now. That's M3, that is 5.45, that is quinkydink, that is quinkydink, or that, well, that's tangent, that is referenced. So none of this should be able to move, but it's saying it's not constrained, interestingly enough. Oh, that is why. Okay. Perpendicular to that. There we go. That's better. Cool, cool, cool. So let's go ahead and extrude these out. Where's my body at? Where are my people at? Actually, because... hold on. So there's a couple things here, right? I guess it will be alright. Alright. First off, being this close to the corner, I actually kind of wanted to do this. Control Z. I actually kind of want to do this and make this look neat, which I guess I can do. Let's see what happens. So if I do this and then extrude all this up, bodies 2 millimeters. That's kind of what I want to do, just to keep it looking neat. Otherwise, if we ignore those lines that I just made, it doesn't look absolutely terrible, but I think I like it better looking square in the corner there. Now I'm going to extrude the hole through, distance all. Flip you. Are you actually going through? Yeah, okay. I see the arrow going up with the 23 millimeters. That's why I was a bit confused there on that one. Now, this actually is what I was thinking. The second thing that I was running into is that I shouldn't be able to rotate this like this around the origin. I'll double check just to make sure I'm not going crazy, but it should be off. Yeah, it is off. You see how it has the gap there? Because we're not a square. Earlier when we were a square, this worked just fine. We were able to circle pattern this kind of stuff. For example, these guys in the middle. Because they're, well, actually these guys are not referencing the edges at all. So since they're not referencing the edges at all, you know, they don't have anything to compare to. But in this case, we're going to have to do mirrors instead. Features, doink doink, and doink. Looks fine. Just again, double checking that I'm not going crazy, and then grab all these guys and do them on the opposite side. And there we go. That is our mounting pattern for the whatchamacallit. Now, this is called, I just realized, So there was something I was thinking here that I didn't say. I started to say it. I started saying we have a design decision on how to position the tilting function. And one of my ideas I had, again, keeping things nice and tucked in, which has been the goal. You know, we've been trying to keep everything nice and tucked in. I was going to have the half circle right here, the pivot point, go on the inside of this wall. So I was going to actually cut a hole in this edge right here for the pivot to go through. Obviously, this guy gets in the way right now, so I got to move him in, I guess. Yeah, I can move him in and we'll still have that option. It's one of those things. Again, I have not committed to how this, how this tilting mechanism will work. So I may be making this change for no reason, is my point being, but let me go ahead and, how do I want to offset this? I guess I'll offset this with a circle is fine. So let's give ourselves 4, 3, 3, 4, 3, 4, 3, 4, 3, 4. Do I want 3 or 4 millimeters? 4 millimeter. Get out of here. 4 millimeters. Let's see where that puts us. This is just a reference line right here. And actually, let me tangent off of this guy because this is the wall I'm interested in right now. And that obviously is not going to, we're not extruding anything up here, so I don't care. It's going through the wall. Yeah, it's not that far into the box. I guess it's all right. Now, the next thing, now that I'm looking at this, now that I'm talking about far into the box, is I'm going to put, again, I'm thinking the tilt mechanism on this side, and this side, obviously, on each side, which means that I only really have the top middle here to put the... Okay, good, that did extrude out correctly. I was a little concerned that it might go, oh, missing profiles. We got to fit all the electronics in here, and we're going to have bolts running through the center here, which is going to complicate things. The micro, let's see how wide the micro is, because we could have the micro and then break it out in line, kind of like if you remember what the chip looked like. Well, I mean, I literally have it in my hands right now. 1 second. So one of those things, we could have a long skinny board like this, and then have the breakouts for the serials, output inputs on the back side here, extended out that way. So that is an option. Not using headers, I would probably use right angle DuPont. Actually, I wouldn't use right angle DuPont pins because we're using JST connectors. Well, I could, it's one of those things. I'll figure out when I get there how I'm gonna exactly solder it together, but we could do something like this. The only question is how much space do I need just for the microcontroller? So the microcontroller, I'm getting 18 on the microcontroller, and this board as I have it cut, which is with just a little bit of leeway on the outside, is 21.5, let's say 22. So let's check the distance between these holes right here to see if we can squeeze it in the center here. Reset that. Let's see if we can fit it between here. So that's 18, so we cannot fit it between these holes. Okay, now I'm getting a little bit concerned. Can we fit it between here? We cannot. Okay. We have reached a bit of a dilemma. Huh. Alright. What this means is we need to back up. So this is getting to be a very exciting stream. Because we are about to propagate a whole bunch of design changes forward into the future and deal with the ramifications of that. So these holes are no longer going to be here. These holes, I guess. Huh. Where are we putting these holes now? Okay, we actually can solve this another way. Again, it is going to probably get messy. Fusion is probably going to have this get very messy on us, but we can solve this another way, which is coming up here into our parameters and changing this to 23, let's say. And then we cry because things are probably going to break. Maybe? I'm not too concerned about these guys being off. That's fine. I was concerned about the slide actually breaking, but I do not see anything. The one thing is that this probably... Yeah, so we need to come back here before... Let's see, right here? Not right there. Okay, yes, right there. Yes, right there. Wait, but don't we do the slide first? What I was going to say is this guy needs to be slid back, right? Because the way we positioned everything is by translating this guy back so that he's away from... do 6. So that's how we did that. Now that's going to change the bolt holes, is what I recall that changing. What else? Did we break anything else with this? Alright, so the bolt holes have now been updated. It doesn't appear that anything went wrong with those guys. I guess the other thing is forwards. No, because this bolt hole is always going to be in the same exact place. This guy should always be in the same exact place. I was only concerned about it going forwards here. So let me drag this. And again, we have this motion link right here, which I never fixed because it's literally been like a day. So I'm going to delete that really quick, just to slide this guy forward. So this guy, when he is parallel with the front side, let me turn this slide cover off. Alright, yeah, that's right there, which is what I was aware of. And let me get a section analysis from the other side. Let me capture position, section analysis, section analysis from over here. Okay, so I can see the inside there. Please stay on. There we go. Okay, and again, my biggest concern right now is that right there, that cutout, and the nut hitting that cutout, which it definitely looks like it's going to, and that probably was a problem before that I just did not look at. So let me Control Z a bit. Control Z, okay. Okay. And Control Z to get me back to, yeah, right there. That's what I wanted. Let me come here and let me move this guy. This guy's tangent right now. What is this? What is that? What is that? That's 5.5 right there. And that's 2. Let me move you back. So the 5.5, in theory, should clear then with that bolt. That bolt should clear in that case. Ha 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 ha. So it's saying that I should have the clearance there for that. If this is working out the way that I thought it was working out. Let us move forward here. That guy, where's that guy at? Okay, I should just extrude that before we even start with this. Ha 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 ha. The bolt's going to be on the inside of that wall anyway, right? Which may be our only saving grace here. Turn you off. Right, this is all... So if this... Yeah, that wall is only... This wall right here, this inside wall, is only as thick as the slide. And the bolt's going to be on the inside of the slide, so the nut should clear that. And this is between these two guys. Inspect. There is 2 millimeters. So the bolt, the nut thickness is about 2 millimeters, which is not great. Let's see. Let us consider. I just have these... Do I just have these guys here to stiffen up the slide? Is that why I put these guys here? Why did I put these guys here? I actually cannot remember. I want to suggest that I put them there just to stiffen up the slide, but maybe I'm incorrect in thinking that. Body back on. Yeah, I mean, it wouldn't be the lid because there's also one at the bottom, right? Maybe I should just suppress these guys altogether. I don't actually remember what I put them there for. Alright, let me come back here. That was these guys right here? No. Those guys right there. And that's just a mirror of them? Yeah. I'm going to suppress these guys for right now. And if I remember what they were for, we will come back to that then. Otherwise, the rest of it... Control Z. Okay, so the top case did not re-extend out. That used to be square. Roll here. Okay, so there's that. That is those guys there. This used to be square. I'm trying to figure out. Unsuppress. Huh. Interesting. What got lost here? I actually don't know. Because I know we resized it, but that we had to resize this plate to begin with because we added this slide on the side. So, all right, I'm going to hop into, let's see. I'm going to figure out, okay, that's my tab right there. I'm going to use this guy and include that guy in this guy. Whoa, what are you doing? Fusion, please. Blocks. That guy. And include that guy as well. And that did not work. Okay, maybe something is going wrong there then. That broke. I guess that would explain that guy. Optimized, okay. Optimized failed, good. Identical. Alright, identical generally works, and it worked again this time. Okay, so before I spend all my time realigning these keypad numbers, let us hop inside the master case and check our sizes again. So, shrink these guys up. I'm going to suppress that link for the time being because it is borked. And turn you guys off. So now I just added all that space in theory. So we have 20 between. Again, I prefer to have like 22, but 18 is what the microcontroller is. So that is close, pretty close. Otherwise, from the top edge here, we have 21.5. That's interesting. I was expecting to get more space out of that, the extra 2 millimeters, than we actually did. Which is interesting. Let me hop back up here to top case and let's see. Let me see this drawing again. Yeah, so there's my 23. Huh. Okay, well, let's look at this guy, or not that guy. This guy then. Okay, this guy is... Oh no, he is still centered. I was going to say, I was looking at this key right here, this button switch. And give me the center point thing here. Maybe I just slide you out because you don't need to be that close. Midpoint constraint, there it is. And maybe we make you... Well, maybe give you a little bit of a radius here. Let me look at the bottom side just to see how much... Yeah, it doesn't really stick out the bottom side away from the whatchamacallits too much. So what I will do here is I'll just give myself a millimeter of clearance and then make this coincidence on that guy. So now he's skewed away from the center, which gives us more space in the center. I could actually do that the other way around. Well, let's look at what that looks like really quick. Come back down to the master case. Because I could have gone the other direction with it, which would give me more space up here. But I wanted to get more space in the middle here. Yeah, so that's my 22. So again, this board that I'm taking my measurements off of for right now, I cut it at 22. That's a reasonable size. So that may just be where we're at this point. So now the board will fit in between here, facing forwards. Well, I mean, I say facing forwards. It should be facing backwards to get the USB cable out. We could actually face it sideways instead. Cut the difference. Face it sideways. So it could be mounted... Whoops, Control Z. Let me just draw here. So it could be mounted in this direction. And then the wires... Where's my line lines? Could be come in... Alright, that did not work exactly the way I was thinking of it. Let's try that again. Boink, boink, boink. Wires could be coming out like that, towards the back, toward where everything gets hooked up, and then the USB cable could just, you know, twist around this way. Obviously move this back a little bit so that we have the space, but come back around this way and get plugged in, you know, the back here. So that's the other option. Otherwise, like I said originally, plan is for the time being to place it here. The USB cable will have to come out here. USB cable there. Actually, I guess I could run the USB cable all the way around. That's easier than running all the wires all the way around. So wires either have to come out the side here, or I could bring all the wires again, because we have significantly fewer wires is the point here. You know, they could come out the center like this, was my original thought, and then go into a breakout board right here, was how I was thinking of it, because we have fewer wires. So, and then again, the USB comes from here all the way around here to go out the backhand side, because I'm not going to plug it into the front hand side. Well, we have the space at the moment, so regardless of how we do it, should be fine. And now we can get back to the important part, which was designing the tilt. So let us do that tilt mount. So, I'm thinking this through. It's one of these things where so if I draw some circles in here, let me draw some circles in here really quick, just to make sure we're all on the same page. So in theory, the way I was going to do this is just to keep a very simple pattern, which is to have something that goes like this, and it's attached to the plate. Should I move this out more? Should I move this out here? Sorry, I'm just thinking. This made sense in my mind, but I'm tilting backwards right now. No, I just don't tilt that direction. Don't be stupid. Okay, gotcha. Yeah. My brain got itself a little bit confused there. So, let us extrude this out really quick. So this is the tilt mechanism right here, which is why I wanted to leave space in the wall right here. It comes all the way down through the base here, and then we tilt this along the corner. So this is my hinge right here. Please, thank you. This is my hinge right here. It goes up, that goes through there, and then we put a little hole running all the way through. Through both of them, and then we lock it in place when we get there. This is actually going to have a slot in it. This is going to be completely slotted, this extrusion. But point being is that we then tighten down the outside when we get it to where we want. So we have a little knob on the outside, and that holds it in position for the angle we want it at. That was what I was thinking. Let us see. Is there any reason not to go that direction? Is there any other designs we wanted to go? Also, for the record, this arc right here could be on the outside. That arc could be on the outside, but I wanted to put it on the inside to hide it. But anyway, per the previous question, is there another design we wanted to investigate? So the other design I can think of is to use a prop instead. So basically, you have a, again, I guess I'll just draw here. You have a hinge on a stick back here that kicks out. It's a kickstand. Actually, that's a better way of putting it. You put a kickstand on here, and then it's one of those things. The more laid down this is, the more of an angle we have here, and then the base down here just has something to kind of keep that in place, keep it from sliding. It's one of those things that's less linear. So obviously, if this is slotted, if this piece is slotted all the way through, you can stop at any point along that arc. and lock it in. Whereas this would, in theory, have, again, little tiny gaps or ridges or something down here for the kickstand to kickstand into. So let's see. I'm trying to think. The kickstand, well, I think in either case we need two pieces. One piece to hold the base. Actually, no, it will be mounted. So one piece mounted to the base, rather, the master case. Mounted to the bottom of the master case is one piece, and then another piece on the floor, because the kickstand obviously needs something to fit into, and the arc also needs something to be attached to. So we do need two pieces there. Does the arc need a piece mounted to the bottom? Again, I didn't think this part through terribly hard, just because I said, oh, you know what, we gotta add it, and I was busy looking at the electronics, so I did not think to it too hard. If I don't have a piece mounted to the bottom here, then this thing just kind of flops around, right? It doesn't keep it. So when we add either of these pieces to the bottom of the master case, it would have a hinge down here to keep this whole thing pivoting, and the only thing we're adding is a mechanism to keep it in place. So I guess since that's the only thing we need right now, we can leave the other stuff for later, whether or not we choose to go with the kickstand or the arc right here. The benefit of the kickstand, for the record, is that we don't have to cut out, even though I moved everything inwards to give myself the cutout for the arc. We don't need that cutout at all if we use the kickstand, because the whole entire mechanism is contained outside of the box. That is the biggest benefit. The only downside to the kickstand is that there's not an immediately obvious way. Well, we could design one. There's not an obvious way to keep the kickstand from moving. So once the kickstand is dropped down, once we drop the kickstand down to put the thing in position, in theory, for example, this box, if the box is at this angle right here, right, with the kickstand coming all the way down to here, obviously that doesn't really work, and this whole entire thing's just going to flop forwards. The kickstand obviously can't hold it down, is what I'm trying to say. Although, like I said, we could just design around that, and we could have a pin that locks the kickstand to the positions, the incremental positions that we have built into the second piece. That is definitely an option. The third option is kind of a hybrid between the kickstand and... I'm going to draw this one on paper, because I think this one's going to be a little difficult to explain in Fusion. So come back to the camera really quick. So the third option is kind of, like I was saying, in hybrid, where we use a folding mechanism. So here's the master case. Here is the desk. And we could have a folding mechanism like this and a bolt system that, when you twist it, straightens this out. So it would be anchored at one side, and then as you tighten it or loosen it, it gives it more flex in here. There's a couple different ways you can actually do this folding method, but it's probably overkill for right now. I think we'll probably just kick... I kind of want to get this... I like the idea that we don't have to cut through the side to put the arc in, so I'm leaning towards the kickstand, and the kickstand is also easier. So the easiest solution to this is just to have the mounting points have holes in them for the kickstand, and then just drop a bolt through it, a pin, anything really through it to keep it from moving. So I think that is where we're going to end up at. It's one of these things. At the end of the day, I'm going to set this thing up on my desk, and it is never going to move ever again, right? In theory. So the fact of the matter is that I'm making this whole entire flexible system that can be rotated up and down as you like, but that feature is never really going to get used, so practically speaking. So I am spending a lot of time talking about it, which may be a little bit of a waste of time. So let's see. I kind of want to come back up here, I think, and do it from the top view. Do I want to do it from the top view? We have the inside, that's the inside bottom of the master case. Let's go to the outside bottom of the master case. Outside bottom of master case. There we go. And the funny thing is that I'm actually kind of partial to designing it from the left-hand side here, because we're going to be putting pinholes in it. And by left-hand side, I mean maybe the middle even. Whoops, Control Z. So if we design it from the middle, basically I just go like this, right? Let me project out. So there's that. This is my 2mm wall. 2mm wall. I swear I hit 2. Just line this up really quick. Let's do that. Turn the body off. Oh, hold on. I'm in the wrong object. Control Z. Come back down here to tilt mount. There we go. So from the center, project that. Let's turn that section analysis. Section analysis is off. Yeah, okay, the body's just see-through right now. That's all. Turn the master case back off. So doing it from the side lets me extrude symmetrically as the one big benefit, and we're doing loops, so I don't have to add those loops back in after extruding it. I can instead cut through the holes and then go from there, from the bottom after I get it extruded. And actually, since I'm in here, so we're gonna need, again, we're going to call this let's see. This is a 3mm bolt for the hinge on the whatchamacallit. That's going to be tangent to, actually I need the head too. So the head's about 5.45, 5.5 like I said before. So there's the bolt head. That's going to need to be tangent to that. And actually, we can just go ahead and make this whole entire thing plastic right here, because that's more than enough wall space for me. How did I end up with a construction line there? Okay. And actually, Control Z, looks like I ended up with an extra line as well. Back to one of those things, Fusion makes extra lines sometimes. Tangent, tangent, right angle. That's not right angle, that is right angle. 1 second. Alright, sorry for the interruption. That was my nephew. So let's get back to the design. Put put that in there. That's, again, our kickstand holder. So the bolt will go through here. The head is about this big, and that is about 2.5 millimeter wall, which is plenty, right? Or 1 1/4, 3 millimeters plus. Oh no, that's diameter. Yeah, so that's in half. That makes sense. So actually, I don't want to use that. I take that back. I want more than that. So let's delete these guys. Yeah, because the diameter is half. That makes sense. In which case, I don't even need this guy altogether. I can just delete that and throw my 2 millimeter wall in there. Turn this solid. And redo everything I just did. Instead of being silly. Alright. Control Z. Delete that. And then make this a 2 millimeter wall. There we go. That's an easier fix. Alright. So anyway, there's our hinge there. And let me I'm trying to figure out, because we want to do the same thing on the bottom right. We're going to have that will be equal to that. That will be equal to that. And we're going to go the opposite way on the bottom. Again, it's the same exact idea on the bottom for the pins. The pins are also 3 millimeter bolts. So I'm tempted to draw this right here and then maybe extrude it later. And maybe just give myself... Actually, hold on. Let me make this... We know that these walls are going to be perpendicular, right? So I'm just going to really quick set this up. And then this is just some spacing right here, just a 1 millimeter spacing to give myself a little space. And I can make that tangent then to that. And this guy... Actually, yeah, I'll give myself a little bit more space too. Nah, will I? So in order for this to sit flat, we actually need the same amount of space up and down. So what I should do is, instead of making this guy tangent right here, give myself that millimeter up here too. Again, I'm just giving myself clearance is what I'm doing right now. For everything to sit flat together. So there is that. That guy, I'm just going to go ahead and... This is going to be a construction line. We don't really need it. Again, I'm just mapping this stuff out right now. And let's see. Yeah, I guess I should have... Well, I'm going to want that to be tangent to that as well. All right, cool. And this, then, in that case, can be equal to that. All right, so after I draw the bottom in here, this should all be... Actually, yeah, let me just... You know what? I was farting around here, and I probably should have just... Let me do this. Drawn the bottom in at the same time. I was thinking, what my thought process is here is that I don't want to extrude all this plastic. I only really need a frame, so I don't need flat sheets, was my only thought, which is why I wasn't going to draw it just yet. But we can always add the holes in next, next, after we have it extruded. So this should be collinear with that. What are you stuck on? Okay, you got attached. That's what happened here. You were not supposed to get attached. So you are now going to be collinear with that. You will be collinear with that. And now we can go ahead and start extruding stuff. And again, we will, well, I'll stop talking and get extruding, and then we'll start talking again after that. So, master case. I guess I will extrude this two-sided instead of symmetric. To object. This is the positive side. Yep, 39.5. To object. There. Again, I'm going to hollow this out because this does not need to be solid, really. It's not really load-bearing. It's just positioning. So, what do I want to do next? Do I want to do... Well, let's get the mounting holes in first. I will get the mounting holes in. So we will come to the bottom here. Bottom down there. Go like that. Project out these holes here. Actually, it would be faster to just project the body. There we go. And then I'll just make the other stuff. Construction lines. Oh, I hate this lasso thing. Why does the lasso even exist? Alright, there we go. Now I can just do all this. And we have the clearance on the bottom here, so I don't need to recess the heads at all. Distance all, cut, flip, bodies to cut, just the tilt mount is good. And yeah, like I was saying, we're going to have material in the way back here, so I don't actually need to recess these bolt heads on the bottom. They'll have clearance. So we will get back to extruding this guy now that it is mounted to the so this is the part that holds the kickstand. So this how do we do this? Yeah, we'll put the kickstand in the middle, right? Yeah, and then we extrude on either side. Okay, cool. So this is going to be a symmetric extrude, and we're going to want let me make it a little bit bigger, the kickstand a little bit bigger. So I'll make the kickstand about 5 millimeters thick, just to make it extra sturdy looking. I say extra sturdy looking because frankly it's probably sturdy enough at 3 millimeters, let's say, but I'll make it 5 millimeters. So we need 5 millimeters in the middle and then 3 millimeters on either side. Again, just for overkill for the funds of it. So that's going to be a total of 11 millimeters symmetric extrude, and that's overall length. So we can join that, and then we can extrude out the hole in the middle for the kickstand. And yeah, I will extrude the whole entire thing. So that's 5 millimeters overall symmetric extrude. There we go. Kickstand will go in the middle there, and then we need the plate. And actually, let me back up, and not that guy, this guy. We can do the bottom plate at the same exact time. That's fine. And then I will go ahead and do this guy. This guy is done the same exact way, but I'm doing it on a separate extrude because I want to pattern this down the line, is why. That is the rationale. So again, 11 distance, whoops, symmetric overall, there we go. Join, and actually, let me back up. I know I just did that as an add-on to this, but this really should be a subcomponent, so let me do that. Distance, two-sided, and I want this to be the same size as this plate specifically, so I will go ahead and do that as opposed to doing it to the master case. And new component, there we go. Mounting plate, un plate, extrude that out. Back to this. Whoops, I don't know why I did that one. Distance symmetric 11. There we go. Join, and then let's turn some bodies off here so I can get to that guy. 5 millimeters symmetric overall. Okay. And now we pattern that down the line. Pattern, pattern, features, that and that, line. Trying to grab this line right here. Turn that off, I guess, to try to grab this line. And then, oh, chain, huh, okay. I don't see a chain select, so let's see. Well, it's one of those things. So long as it works, it works. So let's see if it works. I want spacing. These guys are, let's see, 3 millimeters plus I did a 2 millimeter wall, right? So that would be 2 plus 2 is 4 plus 3 is 7. So 7 millimeters if I want them butting up against each other, which I'm kind of alright with. I'm kind of alright with them butting up against each other. 7 millimeters then. Spacing. And like I said, so long as it works, it works. So I'm just going to go ahead, and even though it's wrapping around the edge there, yeah, let's see what happens. So here's the, alright, I haven't shown this on stream because it hasn't come up, but you see how these guys are staying like this? If you change this path direction thing, you can see it wraps around and flips them over. Just a neat little thing, feature, in case you were unaware of it. But, okay, so one of these things, again, if I go all the way to the front here, that one is this case legitimately like 180 over, because the kickstand is coming from the top basically at that point and coming back to here. So we don't actually need that many. So I'm going to back it up because, again, may as well save some plastic. The question is, that angle, I think, just looking at it, again, could do math. We're lazy. We're not going to do math. But that angle, I think, is more or less up, straight, and down. Like maybe at this angle right here, which is, let's say, about 75 to 80 degrees. I think that's 75 to 80 degrees right now. So that one feels unnecessary to me, so I'm just going to take that off and then say, okay, we're good. So there is that. Now, the next thing I could do, or could have done, one of those things, I could have made this square, and then it would have been a strip with holes in it. I'm trying to decide which I like better from an aesthetic point of view. And actually, let's go one step further. I'm going to turn this case off really quick. Where's that sketch? That's getting in my way. Let me see what happens if I do this. If I try to get in here, I'll grab the other one while we're at it and fillet this up. Okay, it doesn't look like it's going to let me. Oh, no, there it does. Yeah, so I actually do kind of like that, though. I kind of like adding not as much of a spike. I do like the wave right there. Okay, let's do that. So I will keep this like this because I do like how that looks right there. I didn't like the spikiness right here as much, but I do like this kind of wave type pattern right here. So let's go ahead and just pattern along path that guy. Select that 0. Actually, I probably should have left that at however it was at. Actually, you know what? I take it back. Actually. Let us just select more of them. One of those things, not exactly future-proofed at the same time. The along path feature can be a little bit annoying sometimes. So rather than fight it, I will just do this. Now the next question is, do we want to spoof this up a little bit more with like saying, doing this? Does this feel like it adds anything to it? Again, I mean, I really don't like sharp corners, which is the only reason why I'm investigating this idea right now. Yeah, alright, I'm going to put a little bit on it. Just because, again, I don't particularly like the sharp corners. On the inside, I want the sharp corner. Do I want the sharp corners in the inside? I was going to say because the kickstand's going to be in there, but the kickstand's going to be all the way in theory. It's going to go all the way down to the bottom. So oh, actually, so what just stopping right there is it occurred to me that the kickstand starts out laying down all the way across here, which means that as it stands up, it actually uses these guys. So this part right here is the part that is Huh. So it does an ellipse like a cycle, doesn't it? I think it does do an ellipse. Cycle, hyperbole, whatever the heck you want to call it. Right? Because it comes back, starts hitting these guys as it stands up. And then as it goes back over top, then it starts dragging it forwards again. So actually, I think I will add this back in. And then we will have to... What happened there? That's still spacing, so that should still be fine. Huh. Why did you do that? Remember when I said pattern along path can be a little silly sometimes? The preview looks right. Why are we optimized? Nope, not optimized. Okay. Identical. Okay, huh. Huh. Okay. I see you, I see you. I'm going to do this instead then. Take this. Okay, or just completely prove me wrong. Okay. How about I select that guy instead? And go to 1. We got a 7mm spacing, extent, spacing. Okay. What if I use the origin as my path? Not gonna happen. Okay. Understood. Have a nice day. Let's grab that guy again. Try this. And what if I select a different line here? I'm trying to select one of those things. It's not as visible because it's on the other object, but I was trying to get the line in here from this projection. Oh, that projection is right in line. Okay. One. Huh. Jeez. Okay. Jeez Louise. Can I just not chain it, please? Can we just not chain select? I'd really appreciate it if we did not chain select, if we just gave me that one line. Okay. Let's come back in here. Let me delete that. And delete that. And see what happens. Okay. Why are you still selecting along? They're not quinkydink, you see? They're not quinkydink, so you're not allowed to select them along. Oh, Fusion. Oh, Fusion. I'll put them back on since they're not quinkydink. Alright, let's see. Next option. Next option is to do this. I'm trying to click that guy. There we go. Alright, let's see if this works. I'll switch it to that line. 1. Okay. Alright, there we go. That was a bit obnoxious, but we got through it. Thank you, Fusion. Alright. Grab these guys since we added these guys and we didn't pattern them again, because as you can see, pattern along line is not always reliable, unfortunately. And what's wrong with you? You should be fine. Okay, I guess you just were confused about what you were clicking. I can understand that. I'm confused sometimes by Fusion too. Alrighty, time to add in the kickstand then. New component, kickstand. And I will go ahead and, well, we're still working off center, so I'll just work off center. There's that. Project. Bodies. And actually, I should make sure that it fits in here is what I should do. So I'm going to go ahead and, again, give myself a 2mm wall here. That was not the correct dimension. Control Z. From there to there, 2mm. Yeah, in theory it should be the outside, but because I filleted the outside, I just wanted to be extra careful with that one. So we will go ahead and tangent that and tangent that. Same thing on the bottom. So there's that. And then over here, honestly, it should just, this guy did not get filleted, so I'm going to go ahead and just use this tangent right here. So there is that. So this is my kickstand. Okay, I take it back. That is not my kickstand just yet. Let me get rid of the lines that I don't need. Draw that, and then try that again. Whoops. Okay. Turn you off, turn you off. That way I'm not getting bodies that I don't need. Selecting the profiles of bodies I don't need. And now we can symmetric this guy 5mm, because again that is what we said. And then I'm going to just round the corners and we should be good. So this, let's see, 4. Funny thing is that I'm not sure. I probably should have just used. Yeah, I take it back. I take it back. Let me come back here. Make this solid. I'm just going to use that guy instead. And I will throw a circle in here as well. That way I don't have to round the corners manually. Fix that. And normally, I was going to say normally I do the outsides, but yeah, I will still do the outsides on this. The kickstand obviously does not need to be anything special, so this is plenty fine for the kickstand. Let me, actually, it's going to be the mounting plate is what it's going to be. I want to make sure that, actually, I guess it will be both. All right. I want to add back to some recess here for the 3D printing so it's not as snug. And it really doesn't need to be snug, so I'm going to go a full 0.2 here. And I should probably do that before I fillet the outsides. That way the fillets don't get screwed up. And back up here to the tilt mount. Like I said, I also need to do that up here because I don't want it getting jammed up here either. Let's new offset, please. Minus 0.2. There we go. And then I can go ahead and as built joint that and kickstand, and that's going to be a rotator, a revolve around there. I should probably select them in the other order though, just so that the kickstand is the one more likely to move. And I say more likely because, again, it depends on the other relationships on how Fusion decides they're going to move. Modify as built joints, that, and, well, because it's going to be sliding, it's actually going to be sliding. So one of those things, if I wanted to, I could have made this whole entire slot instead of pins and then still used a tightener, you know, tightened it down with a knob. The reason I did not do that is because then you'd have to, when it's down all the way like this, if you want to tighten it all the way like this, then you have to go ahead and reach your fingers in there and tighten it, you know, which this is only, again, what, maybe 10mm, maybe half an inch, something like that. Yeah, 9mm. So that's really hard to get into. I figured with a bolt, if you're going to bolt it right here, you just reach around and you slide the bolt in. It's not that big of a deal. was my rationale here. As for the bolt on this side, this bolt will have a nut on it, but I'm not particularly concerned about actually having the bolt captured, which is why I did not bother on this one. I'm pretty sure it can just free float out in the atmosphere. Alright, the next thing we need to do is the important part, which is creating a pivot on the front here. So again, this whole entire plate, let me grab a sketch really quick. So let's project that and that. And in theory, this is going to have a point around which it pivots, and it's going to be in line with, I guess I need to project that too then in order to get that linked up. So this pivot point is going to be connected to there, and it really, the center of it really should be like right here. I mean, technically speaking, it's going to end up being back here because I need to place something right there. The pivot, two pivot joints, I should say, I planned on putting on the edges, so it's not going to run all the way across, which is why we could have had the kickstand run all the way down to the end. Again, I just did not see the need for that. So, anyway, this is our pivot. I'm feeling like I'm going to screw something up here, which is why I'm hesitating. It may just be me being paranoid. It may just be just put the pivot in and we're good. I just feel like I'm missing something right here on how this is going to pivot, that it's going to interfere with the kickstand here. Basically, how far out, you see how the arc here, the angle that the arc progresses through, changes as we move the pivot point in and out. I think that's what I'm seeing, and I'm getting a little bit concerned about, but it's one of those things at the end of the day, it probably doesn't matter. I'm not doing anything scientific here, so I'm probably just being a bit paranoid. So let's go ahead and draw this in. Again, the pivot point can be exactly like the other two, although I am tempted to countersink the nut in on this one. Actually, the nut and the bolt head, I'm thinking, just so that they're all completely hidden. Since that guy is in the middle, and it's just kind of a loose pivot, that's why I'm okay with having the bolt out there, because A, it's not visible, and B, it's just kind of loose hanging out, keeping the stuff together. It could be a rivet for all I care. It doesn't necessarily need to be a bolt. Whereas up here, again, well, no, I guess that by that logic, I'm being a little bit stupid because I don't want the bolt locking up on the nut here. Yeah, I am being a little bit stupid here. Okay. Yeah, I don't want the nut locking up on the bolt here either. So I was trying to get the, I was just trying to get it hidden was my biggest thought, is I didn't want it poking out and looking silly. But, yeah, if I put a nut on there, then it would tighten up. So that is probably not a good idea. So good thing I did not do that and then have to backtrack on myself. So let's, again, this is going to be designed exactly like everything else. So this is 5.5, 5.5, and this is 3. And then I'm just going to draw a line down and we will call it a day. There's that. Make these tangent. Make these tangent. Do I need to? I don't really think I need to give myself any breathing room. Yeah, I'm definitely not going to need to give myself any breathing room because this is actually going to be dead center here. So let me draw a center line really quick. Well, a couple things. One, am I cool with this being aligned to the front here? I think I am. So that gets me set up there. And then for this guy, let us see. Yeah, I guess I just take this line here. Okay. This is the only thing I was trying to figure out how I wanted to do, but we'll just center this on there. And then this guy, we'll just quinky dink that guy because these guys are the same. This guy, I mean, I can make him collinear. So this guy was collinear with that, which is why he's fine. I can make him collinear here. The other option was just to make him tangent to the circle and then quinky dink here. Either way works. And now we'll go ahead and extrude this out. And I'm only going to extrude 2 of them, a top and a bottom on each side, because those should even each other out. Although I do need to change these back to construction lines to get proper planes. There we go. And I will go ahead and, because I have the bolt head, I will recess this in like 3mm from the edge just to give myself extra space. So from object, there, 3mm. So that bolt head should only be like 2mm. Okay, 3mm offset there is what I meant. There we go. And honestly, 3mm is probably stiff enough anyway, as I was saying, so I can keep that 3mm there. So the bolt head will, you know, not be sticking out this side. It might be sticking a little bit out the front here. Let's see, 5.5. Nah, I mean, I made that the correct size. So yeah, never mind. I take it back. Oh no, that's right. So this wall is actually a little thin right here. I made the same mistake twice in one stream. That's great. Again, this 5.5, I'm going to change back to 2 to make sure we have enough plastic around the edges there. There we go. Same mistake twice in one stream, and I just broke that, didn't I? You are supposed to be quinky dink with this circle. Please, thank you. So there is that. There is boink, boink. And from object, we'll just take the back of that guy. And go 3mm again. And normally this would kind of be a little bit twisty, but I'm going to mirror this over to the opposite side and then we will be good. It will, you know, square itself up. So there's that. Where's my origin? There's my origin. Again, everything is mirrored off the origin right now because everything's being kept center. It's probably a bad idea, as I said before, but for the time being, it should be fine. I really should just be getting the mid plane of these plates, throwing a mid plane, and then mirroring off the mid plane. That's an extra step, and I'm trying to be careful to keep everything square, so it shouldn't matter. Everything should be square to the origin. Alright, so there is that. I can go ahead and drop an as-built joint. That guy and that guy. Whoops, let's try that again. Tilt mount and mounting plate. And the revolve is on the inside here. Well, one of those things, it doesn't necessarily matter where it's at, per se. And did that not join to? That did not join to. Okay. Control Z. Let us come back here. Whoopsies. Let me... Did I not? I could have swore I fixed it. Okay, I must have controlled Z'd at some point. And accidentally lost the spelling correction on planté. Join. There we go. And now we can come back up here. And it's going to stay at planté now. Because... yeah, so you need to be fixed by selecting that guy now. Whoops, not that guy. That is definitely the wrong guy. That face right there. Alright, so that fixes that guy, and then this guy just needs to be replaced with that guy. There we go. And now identical did not work. That is fascinating. Oh, it just did not accept my selection. No, okay. Delete that. No, don't delete that. I'll just come in here. We'll just come in here, open up Planté, and mirror him over. Features, that guy. Select. Midplane, okay. Huh. Oh. Don't have identical on this one. Again, adjust is just being silly. Adjust is adjust being silly. So there's that. There is that. And now I think we are good. Okay. One thing I did want to check though on this guy is, did I pick? No, I did have features because the last mirror dialogue defaulted components, which did not make sense to me. But it is in fact on features for that guy. So back to what I was saying with this guy and this joint right here. And again, it doesn't actually matter where we put this, I don't think, but that's where it's at now. And the last thing we want to do is mount it to my desk. And what I think I will be doing here, let's see. Crap. Okay. The crap here is that this is going to be really difficult to print. I guess, alright, so I can make up for it. Okay, I can make up for it. My intention for mounting this to my desk was to go like this. Project this out. Okay, that was supposed to be a projection. And then do a clip down here. So if you're seeing this, you know, have a clip, pretend this is collinear right here. That and that. So this is a cutout right here. This clip goes around and goes to the bottom of the desk. I can still do that. And I can. The reason I can't do that as is right now is that obviously this wants to be printed straight up and down like this. And if I have this clip down here, that kind of causes all sorts of problems. But I could just print out another clip, like print this out as a separate component and do that, which is what I will do. If I'm going to do that, I just got to think, because I've clipped a few things to my desk before, and the biggest problem is that if I tighten it down, so let's say I have a screw here that tightens this clip and pulls it tight to my desk, right? My biggest problem I found is that the plastic flexes. A, the plastic flexes, and B, the plastic is not terribly grippy. So while it works for light usage, I'm a little concerned that this clip will just slide off my desk if I press too hard on the top of this keypad. Now, again, as I stated before, we made these all 2mm walls because I don't plan on slamming on this keypad. I'm not going to rage quit on my Stream Deck. So I may be, once again, be a little bit more concerned than I need to be. So yeah, you know what? I'm going to print it out like this, and we're going to see how well it works out, is what I'm thinking. Now, the one thing is do I want it to be dead center? I kind of do. I kind of do want it to be dead center, so I just need to make sure I dodge these guys right here. So I'll project that out. Give myself a little bit of space, just like a millimeter, just because, again, everything should line up because it's being printed. I don't have to worry about, manufacturing process being a bit, body, a bit inaccurate. So I'll just give myself my 1mm right there. There's that. This gap right here between here and here can be basically any amount. Let me try that again. There we go. It could be any amount, but it's basically the clearance that I have to get the clip on is what it ends up being. So I only really need, like, let's say, 5 is fine. We'll leave it at 5 and call it a day, because any extra space will be taken up by the bolt that I'm going to put in here. My intention is to put a bolt through the top side here and then suck the bottom half up like this. That's the way I'm planning on doing it. I have done in the past bolts on the bottom, run the bolt straight up into the desk through here, have a capture nut in the bottom here, run the bolt straight up to create pressure. I'm going to try this a different way. I'm going to put the bolt and the nut up here, and actually that's a good point. Do I have enough space here to put a nut? So again, 5.45 is what I need for the nut plus some wall. Well, I guess I don't necessarily need a wall on this. Yeah, I don't need a wall. So that's 8 though, so that is plenty. Okay, I don't necessarily need a wall. I could capture the nut this way because the nut's only going up and down. and the hole for the screw will keep the nut positioned and keep it from sliding left and right. So we actually should be good on that. This should be, because I'm going to put the nut down there, that's like 2 millimeters plus the, yeah, it can just be a 3 millimeter wall. I'm fine with the 3 millimeter wall. And then on the front side here, do I want this any stiffer? Because again, this part, so as I suck this up rather, as this gets drawn up, my experience has been that the bolt driving into the desk right here is going to, let me just unselect that so I can draw this. The bolt going down like this, it's going to start being pushed up right as it pushes against the desk, and my experience is that this whole entire piece wants to flex in this direction, backwards like this. So by making this stiffer, like let's say 5 millimeters, hopefully will be good enough. I mean, honestly, actually, let me, where is that? All right, my spring winder, I have a manual spring winder, and I know this thing flexes when I tighten it down. And I've got like a full, maybe 7 or 8 millimeters on that guy. So, my manual, that's 12 actually. That's 12 millimeters. My manual spring winder, I've actually replaced the base on because it's warped from being flexed before. Let's see. So that's a full 12. All right, this is not looking great at the moment. Let's see. Option number, I don't really want to. I was going to say option number 5, 6, 7, whatever we're on, is to drill it into my desk. So to put screws through. So just make this be a plate right here. And screw. Actually, I don't even need this plate. I could screw the base straight down into my desk. I don't really like that idea because I don't like putting holes into my desk unnecessarily. But it would be an option. You know what? We'll go with this for right now. We'll go this route for right now, and I'll see how bad it really is. And I will try not to tighten the bolt down too much to cause it to flex. So this, I guess I'm just gonna leave at 5 5. I guess I'll leave this at 5 millimeters like the other one. And since we're making everything thick, that will be 5 millimeters now. Actually, I needed that 5 millimeters for the bolt anyway, so that actually might be better off. Let's see. Actually, it just occurred to me I can't go much bigger because that is right there, so I can only go just so big. So 7, 7 still clears. Okay, 7 still clears. Is there any reason, though, to make that any thicker now? All right, I'll leave it at 5. The only thing this top part is holding the bolt, the 3 millimeter bolt. And it's one of those things, the flex does happen on this corner, right? So it's going to be pushing against this corner. So it does play some role how much meat is between that corner. Again, either this is going to work or it's not going to work is what I'm going to come down here. And worst case scenario, I'll get rid of this clip and then drill holes in the mounting plate right here and here, and then just drill this down, or potentially back here as well. So let us go ahead and get this extruded and get it done. Symmetric. 3 millimeter bolt plus like 3 millimeters on each side, 5.45 millimeter hex nut plus like 2 millimeters on each side, let's say. So that's like 7, so that's like 8, let's say. 8 millimeters it is. And this is going to be a new component. This is going to be a clip. A mounting clip. Okay. And now we want to hop inside to the mounting clip. I will go ahead and do from the inside. That way I don't have to create multiple planes. All right. You are getting turned off. There we go. inside top, or top inside, top of inside of mounting clip. I guess that makes sense. So as I said, the nut actually can just slide in here. And you know what? It's one of these situations where let me turn the body off really quick. And let me turn that body off as well. So I am going to grab this center line here. These are all construction lines. Here is my thing, and I'm rotating it because this clip is going to be printed on end like this, okay? So I want the I want this let me just set this so I can get this out of the way. All right, I want this to be my overhang right here, this orientation. So I'm going to make this parallel to that because this is the orientation we're going to be printing in. Here's my 3mm bolt. And again, okay, you know what? Since I'm printing into this orientation, I won't be slotting the nut into the center there. So let's instead just center it as always and extrude it like that. Okie dokies. Makes sense. Since it's getting printed like this, I can't really slot it in the side, so I won't worry about it. So that is going to be -2. That is -21, -2, and then we will get the hole. And distance all, flip it over, hit OK. And then that is that clip done. So again, the bolt is there, the nut is there. We tighten down the nut to suck this up against the desk. Although I should, I said 5mm on the space on the inside there. That is definitely wrong. I have about an inch desk. So my space in here actually needs to be like an inch plus 5mm. So yeah, that's a lot larger now. And that gives me about 5mm of tighten down is what that does. So that is that. Okay. The last thing I wanted to do here is, as I said, we don't need this much material. And I haven't been doing this because most things we have been making have been like boxes and stuff like that. But this is not enclosing anything, so let me go ahead and clear out some of this meat here. That is a fine plane to work on. Project. Actually, let me project the bottom because the bottom has the stuff that I don't want to run into. So there's that. Let's look at it. Turn the mounting clip off right now and then the bodies. And I just want to, again, clear out some sections. So there's a couple ways we can do this. We could add some clearance, like some wall thickness around these guys, and then clear out the extra area. I'm just going to randomly draw a shape in here and say that I'm not getting close enough to anything else to really cause a problem. And by that I mean, whoops, Control Z. I'll just set, you know, let's say 5mm right here, so that's not close enough. And let's center this up. We'll center that up. Right angle. And then, you know what, I guess I will go ahead and give myself this right here to reference off of. So we can go ahead and bump up against that, and we know we won't get close enough to that hole right there. And then the only question is this stuff. So let me draw this in here, that reference line, and we'll go parallel to that, and yeah, okay, I can't do that. That's fine though. I'm just trying to decide how I want to go about this. I guess I'll go perpendicular here. There's a couple different ways, as I always say, that you can do that. let me draw a 10mm hole here. And then I can come tangent to this if I want to. The question is, do I really want to? Or is this enough meat that I'm happy getting rid of here? Which it might be. So we can just set this height right here. 15, it's fine. So we'll do this. We'll extrude all. Obviously, cut. And then... Okay, that actually... no, we should still be able to... So back to it being rectangle, I just realized I was going to circle this guy around the origin, but back to it being rectangle. I was going to do it 4 times was my idea, which is why I did the corner. By doing the corner, I made sure that I wasn't going to run into this edge. It's fine. So let's look at that really quick, how much meat we have there. That is only 3.4. Yeah, okay, so you see how this looks a bit wonky? Because again, we're on a rectangle, so the circle doesn't really work. So instead of doing that, we'll go back to mirroring, and that means that I'm going to draw that plane in that I used as my corner. Obviously, that is not the right sketch. This guy, there we go. 90 degrees, okay. So we'll mirror over that, and then we'll mirror the other way. Create, mirror, features. That I could have gone with the 3 pattern, and it probably wouldn't have looked too bad, but yeah, actually, that does not look... yeah, okay, so back to this being a rectangle. Why isn't that looking right? That's funny, because I took the corner, and I went parallel with the corner. Did I screw something up on this side? That's perpendicular. I figured this was going to be easy, and then all of a sudden... That's perpendicular, that's parallel, so that should also be parallel. That line, when flipped over that side... Okay, so if this line is not perpendicular, then that line's not going to be perpendicular. Okay, I guess that makes sense. Okay. That does make sense, I admit. Let's hop back up in here. Let me do this, just for some sanity's sake. 5mm. Yeah, that does touch there. Huh. Funny thing is that I thought this was going to work. Okay, let's do this. Let me instead draw a circle here. Make that circle tangent to that. Okay, I guess I'm going to delete that right now. I'm going to go ahead and make myself a nice little, a nice little radioactive hazard sign here. Make this 5mm from that. 5mm. We can still center this on that guy. That should be fine. And then my intention was to come over to here and make these guys 60. I think I was making these guys 60 is what I was thinking. And then back to this being 15 right here. Distance all. Flip, flip, flip. Flip. Okay, there it goes. What happened here? Oh, that's what happened here. I see. Okay, so I'm gonna delete that guy. Yep. Delete these two guys, and then back to my circle. Come around here. Circular pattern. Grab that guy. It's a bit wide for a hazard sign, but it's close enough. Alright, cool. Should be, let's see, bottom. How's it look? Let's turn the sketch off. Yeah, it doesn't really look terrible. Okay. I'm happy with it. Doesn't look as bad as the rectangle because the rectangle was off-centered, you know? It was kind of getting more of the, what do you call it? Kind of, I don't know how to describe it. Let's see. Now down here on the mounting plate, I want to do that too, was the idea. And actually, you know what? I don't know if I will do it on the mounting plate is the only thing. So let me come down here. So I was just thinking because I might want to mount this to my desk directly with screws, you know, but those would only be in the front, so I can clear out some of this space here. Okay, fair enough. Do I have a plane? I do not have a plane. I did everything from the center on this guy, so this guy does not yet have a top of plane. Top of mounting plate. Okay, and we are almost done. Again, I have the JST connectors to holes to put in, as well as a hole for the USB cord, but I am not particularly concerned about... well, it's not that I'm particularly concerned. I should say I had some concerns that I wanted to alleviate about how exactly the shift registers, what exactly I needed from that. I want to double check that I was actually thinking of this correctly. So, Control Z. We will not be putting those in this stream until I confirm that I am thinking that this is going to work out the way I thought it was going to work out. 10. Extrude that. This one isn't fancy. Sorry about that. Just one of these things. I don't know that... nothing's coming to me. Nothing's really speaking to me with how to do this one. Unlike the top one. So, because they're stuffing away. Since there's nothing really speaking to me on how to do it, we are just going to put some holes in to save some plastic, and we should be good. One thing to note is that I may not be saving as much plastic as it looks like, just because it's going to add extra walls, extra perimeters around these holes, which will take up a little bit more plastic. The fact of the matter is at 2 millimeters with 0.2 millimeter layer height and 4 to 5 vertical shells. So if it's 5 vertical shells, right? If it's 5 vertical shells, then that actually means that this is a solid block. This has no infill. In which case we will be saving this plastic. However, if it had infill, that infill would have been 5%. Let's say 5 to 10%, maybe 15%. Depends what the setting is. It would have been 15%. 5% I'm getting from the, because I was concerned about infill. The last time I was concerned about infill was the flexible material, and therefore that's the first number that came to my head. The default is 15. I normally leave it at 15 and call it a day. So it would have been 15% infill that we're losing in here, which is not solid plastic. But with it being so short, being at 2 millimeters and 4 to 5 vertical walls, vertical walls, top and bottom walls, rather, if you would like to call it that, we are saving a bit of plastic here. So, with all that explanation out of the way, again, at this point, we have a pivoting, I do not have mounting holes for the Arduino. Is the one other thing that I might have been tempted to add in this stream, is to actually put standoffs for the Arduino to sit on. The only reason I'm not is because, again, I'm a bit concerned about how the Arduino is going to be sitting in there. So that may be something that I just prop up after the fact. You know, fix it somehow after I already have the whole entire thing built. So that is why I'm not adding them to the model right now. Otherwise, we are at this point done. I'm just double checking. I mean, maybe my desk is more like 3/4 of an inch. One of those things, wood turns 1 inch. Wood turns not being actual measurements, but fake measurements that you round off to the nearest 1/4 inch. So call it 1 inch, but it's actually 3/4 of an inch. So one of those things. This point being, this clip is probably a little bit too tall, and I probably am going to need to come back in and remeasure it and adjust it. But otherwise, we are done here, and I was just grabbing some more plastic to color it. So purple is fine. We haven't used purple yet. I have brown up here, right? Yeah, brown. And then what other color have we not used? I should spend some time making some more colors, because I think I've used them all. Oh, I haven't used dark blue yet. Dark blue. There we go. Whoops, that is not the correct object. Give me my dark blue back. Blue. Blue, plastic, 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 plastic matte. There we go. All right, cool. So yeah, that is that. Hopefully this is the last design stream we do on this. This has been a total of about, I think, was it 3.5 hours on the first one, and then 2.25 here. Although part of that was obviously me outroing, because I always have long outros. But we are up near about 6 hours on this design, which I was only expecting to take like 2 hours max. So I definitely spent more time on it than I anticipated. But if you have been following along, thank you for hanging out with me. We will, again, hopefully be doing the electronics next. Obviously, I already have them all breadboarded up for the demonstration. For a demonstration outside of soldering. You know, I didn't want to solder it up and then have you, try to figure out where the heck my solders were going. My solder lines were going. Otherwise, yeah, I will be getting the 165s in at some point, the shift registers, to do the button inputs. Otherwise, I have the 595s for the LED outputs. And the only other thing we could be designing on stream would be the keycaps, but those are extremely simple, so I'm not going to bother, I don't think. I'll just print them out and just say, hey, look, you just loft them up. That's really all it is. Hit the loft button, hit the shell button, give them a 1mm wall, let's say, and then you're good. You're golden. Only other issue would be doing supports. That would be the only other issue. And maybe some wall thickness issues around where it snaps onto the key. So I guess there's a couple things there. I'll see how difficult it is for me to do it personally, and if it is difficult for me to do it personally, I'll do a quick stream on me doing it and the steps I took. Otherwise, again, we will come back to this project once everything is ready to be assembled. And otherwise, we'll be doing stream animation. I started prep to make sure I was doing the stream animation, the pathfinding and AI correctly. I started doing prep work on that. And otherwise, the mini CNC I have the parts for, so that we'll be continuing that little adventure there. And I already told you, epoxy resin not too soon, a joystick not too soon, although I do want to do, again, the analog inputs for a rotary wheel type deal for that. So that's definitely something I definitely want to do, just not immediately because we have these other projects going. And yeah, that's the roundout. So as always, thank you guys for watching, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're in the world, and I will catch you next time.